So as we ended in part one, about graphing this. We needed to get the degree. We saw we had three factors of x with the square, and the leading coefficient is positive, so we got the n behaviors. Then we needed the zeros. Well, the zeros, of course, set the polynomial function equal to 0, which we did here, solved. Now the thing is, with the x plus 2 squared, we have two factors of it squared. So at the negative 2, we knew our n behavior down here to the left was negative infinity, to the right was positive infinity. So now what happened in between? Well, at negative 2, because of the even multiplicity, it bounced. And then the odd multiplicity came through. Okay? Think about it a couple different ways. One way, which we'll look at later, just the sign, S-I-G-N that is. Again, what happens when it doesn't change? Because this x plus 2 is always squared, it's always going to be positive. So this x minus 3 is going to have the effect, or visually, each zero is a door going from positive to negative or negative to positive. And if you go through a door twice, you end up where you're back where you started. Okay? So, let's look at the next two. And I'm going to do the, I could just do writing. Okay, so if we try to do n behavior first, well, this is nice. It's not factored, so we could read it. Its degree is 2. Leading coefficient, get rid of that, is 3, so that's positive. Get my pen back. There we go. So from before, that means if we need to write it out, left-hand behavior of the function and the right-hand behavior of the function of f of x are equal, and they're both positive. Now, what about the zeros? Okay, well, let's see here. Set this equal to 0. And because we got the higher power of x, the square, factor out a 3 and an x. So, x equals 0 or x equal 2. Multiplicities are both 1s because the factor only occurs once. So, time to graph. Oh, not magic pen. Yeah, we don't have to be too terribly precise with this. So 1, 2, 3 would be enough. Label it, of course. So zeros there and there. So n behaviors are both positive infinity, so we're coming from the left side is from positive infinity. Go through and up towards positive infinity. Now we know that because this sure looks like a parabola to us. So we know what that looks like. Okay. Last one. So, taking a look at this again. The degree is 3, highest power of x, leading coefficient as negative. So if we write them down, this is showing your steps, how you got the graph, what it looks like. Make that look a little nicer. So odd degree means they're going in opposite directions. Negative leading coefficient means that its left hand is positive infinity and your right hand is going to be headed down towards negative infinity. Okay, now what about the zeros? 4 terms. Let's see if we could factor. All these right now will be nicely factorable. First thing, I'm going to take a negative out of that whole thing, just to make the numbers look a little nicer to deal with. Oops, that's got to be a negative. 12x and a positive 4. So can we factor by grouping? Picture, wrong way, and these here, first two, last two. So in the first set of grouping, I can take a x squared out, so 3x plus 1 minus the second grouping. If I take that out as a negative 3, that means that it's going to be, not a negative 3. What goes into 12 and 4? That's right, 4. So that will then become a negative 1. To get our positive 4 up here, we got a negative 1 here. Negative. So 2, continuing to factor. The 3x plus 1, x squared minus 4. Now at this point, if you recognize what the zeros are, go ahead. If you prefer, and I think I would right now, just to make sure we get this all the zeros and don't forget one. There we go. And so our zeros, negative 1/3, negative 2, 2. All of these have a multiplicity of 1 because all of those exponents on each of those factors are 1. Now you might say, wait, what happened to this? That's wrapped up here. Can a negative 1, can a negative 1 equal 0? Exactly. So label them. You have to have some kind of scale on your grid or else no clue what those mean. So negative 1/3, so about here. Negative 2, 2. So end behavior. Left hand behavior said it was positive infinity. Right hand behavior said towards negative infinity. Ooh. Better redo that one. What happens in between? With the single multiplicities, they just do that. And try to draw a smoother curve than that. That's the basic idea. Alright. Get working on some of the practice and see what you can do with it.